G'day team, welcome back to yet again another calculus video. Today we're going to extend on a little bit from the previous video where we were looking at whether functions were increasing or decreasing, and we sort of looked at whether derivative equaling 0 as a key point, as a turning point. Now we're going to introduce a little bit of new language around that, so we're actually going to start calling these stationary points because there's no movement in my derivative. There's no rate of change. So they're stationary. So a stationary point of a function is a point where f dash of x equals 0. Now we've done a bit of practice finding the x coordinate, but to actually classify stationary points, we need the y coordinate as well. And there's that little extension we're going to be doing. So it could be a maximum. So at C, at A, they're maximums. It could be a local minimum, so B or D, or it could be a stationary point of inflection, and I'll show you what that looks like in a moment. So this is what a stationary point of inflection looks like. If I'm increasing and then I stop in here, so this looks a bit like an x cubed function, so cubic. There's actually a slight point in time where that derivative or that gradient in there is equal to 0. So this is a stationary point of inflection where it goes increasing, 0 for a bit, and then still increases. Could also look like a decreasing version too. So we can use these sign diagrams that we were practicing in the last video to classify stationary points. So I've got a whole bunch of pluses and minuses and all sorts going on. Now, if I actually draw in what an increasing function looks like, it's just a little line going up. And then here I've got a decreasing one. So this kind of looks like a maximum because the point is at the top. Then I've got a negative and a positive. That looks like a minimum. If I have two pluses in a row, so there's no clear maximum or minimum, then we say that's an inflection point. Another maximum here, and then if I have two negatives, it's also an inflection point, okay? So general rule of thumb, if I have a plus then a minus on my sign diagram, it's a maximum. If I have a minus then a plus, it's a minimum. And then if I have a plus and a plus or a minus and a minus, they're inflection points. So when a question asks you to find and classify the stationary points, we're finding the coordinates of the maximums, the minimums, or the inflection points. And we'll go through an example together. So find and classify all stationary points for f of x equals x cubed plus 1. Now, I'm actually going to, no, we'll leave it like that. We'll leave that function there. So the process we are going to do is exactly the same as the last video. We're just adding a little step on at the end. So let's find the derivative, f dash of x. So that is 2x squared, and that 1 drops off to be 0, so there's my derivative function. Now we find where this f dash of x is equal to 0. So f dash of x equals 0, therefore 2x squared equals 0, and that means x has to be 0. So let's create a little sign diagram. Doesn't have to be big because we've only got one point of interest. Now I'm going to choose -1 and 1. If I choose -1 in here, all right, so -1, I'll put it into here, I get +2. And if I put +1 in, I also get +2. So I'm going to draw in my little lines that represent these. And I can see I've got a plus plus. So that means I've got a stationary point of inflection at x equals 0. Now that's super close to being a full answer, but we don't have the y coordinate of that. We don't know if it's going to be on the x-axis or not. So to find a y coordinate, we substitute our x back into my original function up here. Okay, so that means I'm substituting in 0 cubed plus 1, which equals 1. So that means at the coordinate 0, 1, there is a stationary point of inflection. Now, if it was a maximum, then we'd do the exact same thing, find the coordinate, and we'd say that there's a maximum. Same thing for a minimum. Hopefully, that helps a little bit with classifying stationary points. So same process as we did in the last video. We're just substituting those key x values back into my original function now. We'll catch you guys in the next video.